So in this video, I'm going to show you how to solve equations like these that have rational exponents. So here's the deal with solving an equation like this in part A. What I want to do is isolate the term that is being raised to this fractional exponent. So what I'm going to do is add 9 to both sides of this equation so that I can isolate this term. Now, just like with radical equations, if I have the nth root of a and I want to eliminate that radical, the way to do that is to raise it to the nth power, right? But remember that a radical is the same as a base to a rational exponent. So if I have a base raised to a rational exponent, the way to eliminate that exponent is to raise it to the power that is the reciprocal. So that's what I'm going to do here. Since I have x to the 2/3 power, but I'm really trying to solve for x, what I can do is raise both sides of this equation to the power 3/2. And when I multiply 2/3 times 3/2, I get 1. So x to the first power. Now on the right hand side of this equation, I have 9 to the power 3/2. So again, remember, if you have those fractional exponents, they're really just the same thing as radicals. In fact, if you have a base raised to the power m over n, that's the same as the base to the power m and taking the nth root. So here I have x equals 9 to the 1/2 power cubed, which is also the same as, let me just write that here. Right, I can rewrite 3/2 as 3 times 1/2 here. And the 1/2 power is the same as taking the square root of 9, which we happen to know is 3. And then all I need to do is take 3 and raise it to the 3rd power. So x is 27. Now, there's one thing we need to remember here. When I'm taking this square root, I need to have that plus or minus here. And when I cube a positive 3, I'll get a positive 27. And when I cube a negative 3, I will get a negative 27. So I can verify that both positive 27 and negative 27 satisfy this equation by substituting them in. So the solution set for this equation is negative 27 and positive 27. Now in the second example, we're going to execute this exactly the same way. The only difference is the base consists of this entire quadratic, and you can see that this is already isolated on one side of the equation. So step 1 is already finished. Whatever is being raised to your fractional exponent, isolate it on one side of your equation. Now, in order to get rid of this fractional exponent, I'm going to raise both sides of the equation to the reciprocal of that exponent, which in this case is 4. When I do that, I'll be left with this quadratic on the left-hand side, and on the right-hand side, I'll need to compute 3 to the 4th power. Now what I have is a nice quadratic equation that I need to solve. So what I'm going to do is collect all terms on one side of the equation and then solve this quadratic by factoring or the quadratic formula or whatever method seems appropriate. And in this case, I think I can do some factoring. It looks like there's a GCF here of 32. And this quadratic here looks like it can be factored even further. And then I'll use the zero product rule, set each factor equal to 0. And as always, I need to check that my answers do actually satisfy this equation, which I've already done, and they both do. But remember, this is something you need to do when you're solving equations like this, is you need to substitute these solutions back into the original equation and make sure you get a true statement. If you do not get a true statement, then that solution would be an extraneous solution.